Florida scientists are preparing for a commercial revolution in space.
They can either dig or dump, so clockwise or counterclockwise.
And they're figuring out how to build roads and buildings on the moon.
Well, I believe that this is the largest high-fidelity lunar simulation facility in the world.
We'll show you the experiments and the designs.
This one channel alone can process 20 kilograms per hour.
I'm Craig Patrick, and we'll work through plans to colonize the moon and Mars.
We're on the surface. Let's evaluate.
And reveal how it could pay off in ways you may not believe. All in this edition of Breakthroughs in Science. We'll start with an easy question. Name this planet. Is it A, Earth, B, Jupiter, C, Mars? Lock it in, and yeah, that's a trick. It's not Earth. It is a rendering of Mars back when the red planet was blue, before Mars lost much of its atmosphere and water. NASA scientists used some very large infrared telescopes, including the aptly named Very Large Telescope on the bottom left of your screen, to study water molecules in the atmosphere of Mars, and then map the ratios of water molecules, analyze the dried river and ocean beds, and study the polar ice caps. And they determined around 13% of Mars' water froze, while the other 87% got lost in space. And this all suggests that Mars used to be a lot like Earth. These are animations showing how Mars likely looked more than 3.5 billion years ago. It was likely habitable before it dried up, thinned out, and cooled off. And now Central Florida scientists are developing technology to transform it to make it more like Earth once again.
It would be like a cold winter day in Florida.
Yeah, probably, yeah.
Now, before we explain UCF Professor Ramses Ramirez's work to transform Mars, let's start with the context. Why we would want to send people to Mars? Well, the first reason is to try to find life on another planet.
This is the real, I think the holy grail for science is, are we alone in the universe?
In 1984, scientists discovered this Martian meteorite in Allen Hills, Antarctica. And in 1996, scientists discovered what's inside it. This could be fossilized remains of microbial life from Mars.
If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered.
Well, after that, NASA stepped up its surveillance of Mars. In 2013, the Curiosity rover drilled into a mudstone in what we call the Cumberland drill site. And that revealed organic molecules. And then researchers also confirmed the presence of long-chain hydrocarbons, which could be fragments of fatty acids. Well, for context, life on Earth is made up of organic cells, of course, surrounded by membranes with fatty acids. So the evidence of life continued to grow. The Perseverance rover collected samples in the Jezero crater, which used to be a lake with an inflow channel and an outflow channel. Well, if there's microorganisms on Mars, if there were or still is microbial life on Mars, that could be a very good place to find it. But see, it'll take another decade to get those samples back to Earth, which leads to the growing interest in sending astronauts directly to Mars to collect samples and bring them back themselves.
This is actually possible with our current technologies.
Well, it would take 9 months to get to Mars one way, and astronauts would need to stay more than a year before they return, which of course carries a good deal of risk and would therefore require a lot of political will. But it could pay off in ways a lot of people may not imagine. Beyond looking for extraterrestrial life, we could take our first steps to colonize another planet and in the process enrich our own.
There's a lot of mining materials there, so we have close proximity. Also from Mars, it's close to the asteroid belt.
And Dr. Ramses Ramirez is interested in finding and mining loads of helium-3, which we've already discovered on the moon.
We are able to mine the helium-3 resources. We have enough energy to power the world for a century or something like that, just on the moon. But then the outer planets have almost infinite reserves of that.
That would require building a permanent human colony on Mars, which brings us to the UCF professor's plan to make it more like Earth.
Well, first, we want to start small.
Ramirez worked the science to conceive a fountain on Mars. See that fountain kicking up that red plume? That's the idea, except that's not Mars. That's a volcanic eruption in Hawaii, but it can help us visualize the concept on Mars. Engineers would develop a device that sucks up Martian soil, then forms it into tiny specks of cylindrical nanorods, each one smaller than a speck of glitter, then spews it out like a fountain to form a thermal blanket in the lower atmosphere of Mars.
Then those particles would be interacting with the solar radiation and bring a lot of that radiation back down to the surface, to the lower atmosphere. So you warm the planet.
And Ramirez said we could start small, achieve this effect in relatively small patches, warming them up to around 30 degrees Fahrenheit.
You can really intensify it, create like a local greenhouse effect on a local area, and at least get temperatures up.
Meaning you'd still have to wear a suit and a mask to breathe, but it would be a lot easier to get around to then work on enriching the soil and hopefully start growing plants, producing oxygen, and so on.
It'll just be like a second Earth.
And while this may sound like crazy talk, remember airplanes sounded crazy to a lot of people before the Wright brothers. And then remember how quickly commercial aviation advanced in the years that followed. And right now, with the dawn of AI and the coming age of quantum computers, we expect our progress and our capabilities to rapidly accelerate in the next 20 years. It's why Mars could be a stepping stone to Jupiter's moon Callisto, and beyond that, long before you may expect.
We're getting close to the technology to be able to start going to the nearest stars. So by the time we were able to colonize Mars, we could very well have the technology to go on to other star systems and move on from there.
It's why Stephen Hawking joined the Breakthrough Starshot before he died. That program's working on light sail probes that can travel 100 million miles an hour as they aim for the Alpha Centauri system 4 light years away. Mars is just the start.
Of course, we have to respect other civilizations that we may come across, but
Even the Borg?
even the Borg, yeah, we don't want to get assimilated.
Coming up, see why commercial industry could take off on the moon and what Florida researchers are doing to figure out how to live on the world's first moon base.
First bowl to the right and just plop it in there.
All of it?
Yeah, it's all of that.
Well, this is a powder you do not want to breathe.
You can see all the fluffiness of it. That's why we're in a master.
And it's one of several exotic ingredients.
And this is pepper, right?
It is not.
And when we stir them all together,
We can kind of start feeling around here.
All right.
it feels like something out of this world.
Oh, wow.
Yeah, what are you feeling again?
Well, it's a very, very, very fine powder.
Exactly.
It's getting awful dusty.
We just made moon dust, or to be more precise, it's a carefully formulated simulant.
It's all the right minerals mixed in the right ratios with the right particle sizes.
The Apollo astronauts brought back lunar soil or regolith for chemical analysis, and scientists at UCF traveled to mines around the continent to find the perfect match.
They started buying it in bulk, tons at a time, shipped here in gigantic one-ton bags.
Well, they let me suit up and dig into it, but researchers do far more important things, like testing robotic rovers, wheeled traction, and much more to help us make the next giant leaps.
So we're going to build a robot park on the moon, and we'll be sending our technologies, uploading our software, doing the tests remotely.
Because it can pay off in ways we couldn't imagine just a few years ago. When the United States canceled the Apollo missions, we did not understand the potential of exploring the moon. But decades later, probes revealed water ice beneath the surface. See, the top 3 inches are dry, but the next 10 feet are wet. And the lunar South Pole is the mother lode. It's filled with ice like we have here on Earth because a planet called Theia smashed into Earth long ago, creating the moon as we know it today.
Theia collided with the Earth, and then some of the Earth got blown into space, and it mixed with Theia, and then some of Theia Theia combined with the Earth and sink down inside.
So the plan is to use robots to mine the soil for minerals and ice.
So the shoulders can come up and down and the bucket drums can spin. They can either dig or dump, so clockwise or counterclockwise.
And we can use the ice as rocket fuel. Specifically, we could build a solar farm and use it to heat the ice and then split the water molecules into hydrogen and oxygen.
And it doesn't make sense to do that here on Earth because it would take more energy from solar power than you would get out of electrolyzing the water, but in the moon it's a different story.
That's right. On the moon, an ounce of water has the same value as an ounce of gold.
Because we can then use it to produce bursts of steam, and then we can use that energy to launch spacecraft in ways that in time should be much easier and much cheaper than all the rocket fuel we have to burn to launch from Earth. And that means that we could launch crewed missions to Mars and beyond. We could launch communication satellites to orbit the moon and launch communication satellites to orbit the Earth from the moon, because it could be much cheaper to launch from the moon instead of up from Earth. Of course, it'll take a while for the mining processes to become efficient and bring down those costs, but when we get there, look out.
And that can actually create a huge cost savings, and that makes the data communication satellites cheaper so that data services on the Earth become cheaper.
We could also build power stations on the moon and antennas that could convert solar energy to microwaves. And in time, they could beam clean energy to Earth at lower costs than anything available today. And that energy could also power data centers on the moon. Because as AI takes off, it's helping us figure all this out. But since AI demands so much energy, it's also taxing our power grid. And as it keeps advancing, it'll place a growing strain on the grid until we move them off of planet Earth.
So as the launch cost comes down and as the environmental impact fees for putting servers and energy systems on the Earth goes up, it's naturally going to drive this into space. There's at least 5 companies now that are working to develop data servers in space. One of these companies is called Lone Star Lunar. They're located in Tampa, Florida.
Lone Star has already put a data server on the moon. It arrived in March of 2025 on the Intuitive Machines lander.
We started getting telemetry from our payload, which is like a heartbeat from the payload. I went, oh my gosh, we're on the moon. It's so cool.
And we could also eventually mine helium-3 on the moon and use that to produce more energy through fission. And within the next decade, we expect exponentially faster quantum computers to combine with AI to accelerate our progress.
Once we've got quantum computing, I think it's going to be an explosion of understanding of biology. We're going to be able to solve biological problems to help humans live beyond planet Earth.
Now, we already have quantum computers, but the early prototypes require very cold conditions and they require helium. Well, once again, we can connect the dots right back to the moon.
Right now, there are at least 2 companies planning to do mining of helium on the moon. When we do quantum computing, it's going to require extremely low temperatures. And the only way to get to such low temperatures is using liquid helium. So they are thinking that might be the killer application for mining on the moon in the near term.
And that brings us back to what they're doing in UCF's Exolith Lab. Coming up, see the experiments. We'll explain how we could build lunar landing pads and make bricks for moon bases and build robotic mining colonies. Dr. Phil Metzger was an engineer on the Space Shuttle and the International Space Station. And now he's a planetary scientist at the University of Central Florida with one of the coolest jobs you'll ever see.
Well, I believe that this is the largest high-fidelity lunar simulation facility in the world.
He's part of a team at UCF's Florida Space Institute that's developing plans to colonize the moon.
I really want to have a branch of our campus on the moon, and I think it's feasible.
Now, there are 3 big reasons to go back to the moon and this time to stay. The first is to help solve the mystery of existence. The moon contains a record of the history of the inner solar system, a record of how water got delivered to the Earth and how carbon possibly got delivered to the Earth, and therefore what made the Earth into a life-supporting planet. Much of that evidence got destroyed here on Earth because the crust is constantly reworked.
But that evidence is secured on the moon, and it's like the moon is Earth's attic.
The second reason is to build a launching pad to Mars, and we can do that by mining moon ice and using solar power to turn it into rocket fuel.
I think that by building a mining and rocket fuel production facility on the moon, we can cut the cost of Mars missions by an order of magnitude.
The third reason is to relocate industry that consumes a lot of energy and natural resources here on Earth and offload it to the moon. For example, there may never be an upper limit to the amount of AI that the world demands, and that will place a rapidly growing strain on our environment.
But there's no reason why we can't put that AI off the Earth into space. But we need material. We need material to build the infrastructure for AI servers and for the energy systems.
Well, there's billions of times more energy off the planet in space than there is on the planet. And so if we can tap into those resources, we can grow a much greater civilization without harming our planet. That's the whole idea here.
So we need vehicles that can do mining and construction and manufacturing in order to produce those materials so that we can start to move Earth's economic burden off the planet into space.
And that will require larger landers than we used in the Apollo days, which presents the first big problem they're trying to solve through experiments with simulated lunar soil and with physics.
The way that it blows the dust is actually remarkably similar to a real lunar landing.
And unlike the smaller Apollo landers, larger craft with more rocket exhaust can blow massive, damaging dust storms and blow craters in the landing site.
It made a crater. It made this hole. And this did not happen during the lunar landings.
And that can cause the vehicle to tip over and blow rocks into it and destroy the engines.
Still just surface erosion, and now boom, there's the transition. When it made a hole, it shot a plume straight back up at the vehicle.
And as they figure out how to control the cratering and the dust plumes, they're also figuring out new ways to build stuff. One of the big questions here is, how do you make concrete on the moon? You wouldn't want to use precious moon water and then let that evaporate into space. And that wouldn't really work anyway because there are no natural binders in lunar soil to make it harden.
What if you use microwaves to melt the lunar soil to harden it into a concrete-like substance for landing pads or roads or buildings?
Well, that could work, but the problem with using microwaves is that it takes a lot of energy and a lot of it would be wasted unless the top layer of the soil is highly magnetic, and it's not, unless you separate the grains within it, and that's why they developed this machine. It's a moon grain sorter.
And this one channel alone can process 20 kilograms per hour.
Grains rattle and rub against one another and develop charges and then pass through a magnetic process.
Yeah, you can now clearly see 3 channels, 3 piles, which will further go into different channels.
It sorts the minerals into separate piles based on how magnetic they are.
And then we can pour the highly magnetic ones down on the surface of the moon and then microwave it, and we proved that we can reduce the amount of energy by 70%.
And that means it would only take about a third of the energy systems to build a landing pad and buildings compared to traditional methods. And machines can do a lot of that work.
So this would be digging into the lunar regolith and storing it inside of these bucket drums. And then if they were to turn the other way, that would be when you want to dump out the regolith.
And we can control those machines remotely from Earth if you make the proper adjustments.
When you try to operate robots on the moon from the Earth, there's a 3-second time delay as the radio signal goes up and then as the video comes back to see what happened. That extra 3-second time delay makes it very difficult to control robots.
Which is why they're developing AI to manage the time delays.
So that you can have an operator who thinks they're driving a robot on the moon, but they're really driving a digital twin.
That's one reason why the rovers in the Exolith Lab move slowly.
Then the simulation is driving the robot on the moon and managing the 3-second time delay so that when things on the moon don't happen the way the simulation thought they were going to happen, the simulation has to resynchronize without confusing the operator.
And it's all coming together, from labs in Central Florida to designs for a research base and plans for a commercial revolution on the moon. We have an in-depth look at the plans for exploring the moon and Mars and far beyond on the Fox Local app. Look for the section called Breakthroughs in Science. Coming up, scientists are discovering new ways to detect toxin in our air and water. We'll show you their work and a sneak peek of our next episode. When toxic algae infests our lakes and ponds, it emits some of the most potent natural poisons on Earth.
And when the water looked like split pea soup, guacamole, I still saw people at the fillet tables pulling fish out of these waters, still eating them.
In our next episode, we'll explain how and why it forms in our water and how it drifts into the air.
It turns into a powder, and then the winds would pick up that powder.
And we'll show how scientists are discovering new ways to prevent it, and when they find it, get rid of it. We'll take you from the water to the labs in our next edition of Breakthroughs in Science, and you can catch up on any of our prior episodes you may have missed by clicking on the Fox Local app, scrolling down, and streaming away. And thank you for watching this edition of Breakthroughs in Science.